I wanted to explain just a little bit about trig identities. It's the subject of 7.4 through 7.7, and it's a thing that's kind of difficult for a lot of students. And so I want to talk about really just two topics: the why and how. Okay, why do we need them, and how do we prove them? Because it's really two different questions. So first of all, a trig identity, it's an equation that involves trigonometric expressions, and that equation should be true for every value of the argument theta, for example. Um, why do we need them? Well, one of the big things is that there's a lot of kind of redundancy in the definition of the trigonometric functions. There's 6 functions with their sines, cosines, tangent, secant, cosecant, cotangent. Um, and technically, we could get away with really just using one of those instead of all 6 of them. However, a lot of our work is simplified by having that redundancy, having 6 expressions. So since they're kind of interconnected, there ends up being a lot of different ways to replace one function with another one, is the way to think of it. And the reason that we really need it is to do a lot of kind of our computation stuff. We need to be able to rewrite and simplify. And so for now, what we're going to do is we'll use it mostly for equation solving. We'll use that kind of as our application for trig identities. The motivation is we want to solve these difficult equations, and a trig identity will give us a way to rewrite the equation in a solvable way. Later, and kind of the reason that we have this is you'll also need this for integral calculus. When you take your calculus class, you'll see that some of the computations you have to be able to simplify the expressions just to be able to do the computation. So that's a little bit about why we need them, is mostly to replace expressions. Now, how you prove them, that's a different thing. And if this were an in-class kind of a class, on-campus kind of class, we would spend maybe a little bit more time with worrying about how to prove them. But basically, there's a couple of different ways. The typical way is you start with one side of the thing that you want to prove and simplify to the other side. When that doesn't work, what you can do is start with one side and simplify it, and then start with the other side and simplify it down to an equal expression. Alright, so kind of do the two sides independently to equal expressions. And that's kind of the one-side approach, okay, which is really common. The other way that you can do it is start from an equation that you know to be true and then manipulate it to kind of the goal statement or the statement that you want to prove. And those are kind of the couple ways that are legal. What you can never do is assume the equation that you want to prove is true and then go from there. So that's the one pitfall that is really common when people are worrying about how to prove a trig identity. You do not start with the equation you want to prove and then simplify it. That's not valid. It's an invalid argument, we would say. So that's a little bit about trig identities. It's the subject of these sections. Keep in mind that a lot of these are somewhat complicated, and on the final exam I'm giving you that one page of identities. I'll hand it to you, and it's in your book. It's at the end of chapter 7. And so a lot of these formulas, you'll have them at your disposal. You won't have to memorize all of them. That being said, there are still some basic trig identities, for example the Pythagorean identities, which you will be expected to know. Okay? Well, I hope that